Hello, I wanted to show you a few examples. We had discussed this morning in class, but since we had some technical problems, I felt important to do this one more time. This problem, 11.2.2, it says a 24-hour rainfall depth of 5 inches. So this is the rainfall depth of 5 inches, and it's a 24-hour duration. This is in New York City, but it could be in Italy or El Paso. What's important here is there's a 10% chance of being equaled or exceeded in any given year. So you know that this here is the probability for a specific year. Determine the return period for this rainfall event. Also, determine the probability that this event will be equaled or exceeded in both years. So, here you have the probability, which is P, of occurrence in a specific year, which is 10%. So what we have here is 0.1. There's a 10% chance that there's going to be a 24-hour rainfall of 5 inches in New York City. That has to do more with the 24-hour duration rainfall than the 5 inches, because that 5 inches would be specific for New York City. The 24-hour rainfall for El Paso maybe is different. But then the return period here is going to be very important, because the return period is 1 over P, or 1 over 0.1, which is 10 years. So this 24-hour rainfall, the chances of happening in 1 year is 0.1, or this type of rainfall will occur every 10 years. The 5 inches, as I said, would be specific to New York City, because this rainfall may be different for El Paso. So the next question is, determine the probability that this event will be equaled or exceeded in both of the next 2 years. So then the probability for the next 2 years is going to be P times P, which is 0.1 squared, or which is 1%. So there's the 1% probability that this event will be equal or exceeded in the next 2 years. You can pause if you want to review the solutions. Here we have problem 11.2.8. Remember, this is the 5th edition of your textbook. And what I have done here is provided you with the figure that is referring to here, which is 11.4. So one of the things that I have mentioned is that there's 2 important details that these graphs give us. And there's 2 important details. Number 1, that as the duration of the storm increases, the intensity decreases. As you can see, here is the intensity, and this happened for all recurrence periods. Okay? For 2, 5, 10, and 25. That's the first detail. The second one would be that as the return period increases, like from 2, 5, 10, and 25, the intensity increases. So for example, if we have a specific duration, so let's talk for a specific duration. Here is for all return periods. So as you can see here, as you increase from 2 to 25, you have increased the intensity. So those are the two main things. The other thing I wanted to mention to you was that this is an IDF curve, intensity, depth, frequency. In this case, we only have here the intensity, duration, frequency, not depth, duration, frequency. And this is in the form of a graph, okay? But then we can find in some guidelines, instead of a graph, an equation, which is what you find in the El Paso drainage manual. So instead of giving you these graphs, they give you the equations for intensity at different durations. So if it's 10 or 25, so this subscript here in your drainage manual is what gives you the indication of the return period. Okay? So now let's go back to the problem. Based on that fact, which storm do you think produces more rainfall? A 10-year, 30-minute storm. So you're going to compare a 10-year, 30-minute storm versus a 10-year, 60-minute storm. So the question is, which one produces more rainfall? So if we were quick to respond to this question, you would say, you know, this here is 30 minutes, this here is 60 minutes, and the professor said that longer duration storms have lower intensities. So the intensity for this 30 minutes should be higher than the intensity for the 60 minutes. So you could think that, but the question is not about intensity. The question is, which one produces more rainfall? And whenever we're talking about rainfall, we refer to either volume or depth, right? So remember that whenever they ask a question about volume, look for the units, because hydrologists sometimes refer to depth as volume. So you need to be careful. Always read what are the units that they're asking. Generally speaking, as engineers, we refer to volume as depth times area, right? So volume would be the depth times the area. So then let's take a look at the depth. So the first thing we have to do is to find out what is the intensity for those storms that are described here. So first let's look at the 30 minutes. So we're looking at the 10-year. Oops. We're looking at the 10-year here. So we're looking at a duration of 30 minutes and a duration of 60 minutes. So this is the 10 and this is the 10. So I have to look for the intensity for both. So the intensity for the 30-minute storm would be about 3.4, and the units are always very important, inches per hour, whereas the intensity, and this is 10-year, this is 10-year, and the intensity for the 60-minute storm is about 2.4 inches per hour. Now the question is not the intensity, as I said, but the depth. So whenever we look at the depth, then we have to multiply the intensity times the duration of the storm to see how many inches that is. So I will multiply this. If it's a 30-minute storm and I have hours here, that's half an hour. Okay. So this would be 1.7 inches. And for this specific storm, 60 minutes, then it's 1 hour, so it's 2.4 inches. So what you have here is that the 10-year 60-minute storm produces a larger volume of rainstorm than the 30-minute storm. And going back to my original comment of, if you just look at the intensity, you see that the intensity here is larger for the 30-minute than for the 60 minutes. However, the actual depth for the 60-minute is larger than the 30 minutes. So that's why it's important to always do these determinations.